Good day, everyone. It's me again, Jayp from CS2. So, today I'm going to explain to you about a sorting algorithm called the Radix sort. So, for that, we have here a problem. So, we are going to sort the student ID. So, using Radix sort, we are going to get the numbers at the end of the student ID and then sort it to ascending order. So, we first import time. We will use this later to get the execution time of the program. So, Radix sort uses a subsorting algorithm called the counting sort, in which counting sort is used to sort numbers limited to a small amount only, like 1 to 9 or 1 to 5. So, to use this, we first get the number of elements we have in the array, and we also create another list which will serve as the output, and then a list of zeros that is, or a list of zero with the size of 10. So it serves as the counter for the occurrences of numbers from 0 to 9. So next is we traverse the list, then we use the substring method to get the numbers in the student list, which is this. So it starts from 3 up to the last number. So, and then floor divided it by place value. So the place value is given as a parameter. Here we use the place value. So the place value is used by the radix sort to determine where uh, where or what's the place value are we currently comparing, or the are we currently sorting. So after that, we count the occurrences of the given number, and then we update the position. So here in counting sort, we add the positions of, or we add the number of occurrences of every element to know the initial position of the number. So after that, we put the numbers in the output given their specific position. So we get the position, then after that we put it in the output list, then we decrease the count to avoid putting the same value in the same index. So, and then we copy the output to the initial array, and then after that, so we get the maximum number of digits, which is, for this is 2. So the maximum number of digits is 2, so there are only two place value, the ones and the tens. So we use counting sort for the first place value, which is the ones, or here it's the number in the rightmost position of the student ID. And then after we sort that using the counting sort, we move on to the next place value, which is the second to the last in the rightmost. So after that, we return the sorted array. So let's print it out. So as you can see, it was sorted from student 1 to student 5, 9, 12, 25, 31, 40, 55, 62, and 99. So now we will use another type of sorting algorithm to sort the same student IDs. So here we have the selection sort, in which we first get the minimum index. It serves as the index in which we will start comparing. So selection sort is divided into two, which is the sorted and the unsorted. So the min index serves as the start of the unsorted, and then so we compare the minimum index to the next index, or we compare the element, the minimum index, to the next element, and then after, if it is lower, so we are finding the ascending order, so we will get the lowest value in the unsorted list, then we will put it in the sorted. So we get the minimum index, then we get the current number and the minimum index. So if the current number is less than the minimum index, then the minimum index is changed to the index of the current number. So after that, we swap the current and the minimum index to arrange its value, and then we return the list. So now let's run this code. So as you can see, it was sorted properly. 1, 5, 9, 12, 25, 31, 40, 55, 60, and 99. So let's now compare the execution time of both algorithms. So for Radix sort, it takes 0.996590 milliseconds to run, and then for the selection sort, it takes 1.999748 milliseconds. So as you can see, selection sort takes longer time for it to be executed, because the time complexity of selection sort is O of n squared, while the Radix sort is only O of n times k given the number of digits. So that's the end of the program. Thank you.